Hi everyone, welcome back. This week we don't have any quizzes this week. The next quiz is on the Friday, September 16th. Okay, so uh, we have daily homework. So because I don't want to set 38 different homework due dates, that's why I only set 4 homework due dates. But all these homeworks must be complete by the September 26th. So even though I set a due date here, but doesn't mean you want to wait until that day to finish your homework. I hope you can finish your homework on a weekly basis. That means if the first week we cover 1.1 and 1.2, please finish your 1.1 and 1.2 homework over the weekend. And the second week, we talk about 1.3 to 1.5. Please finish the homework on 1.3 to 1.5 over the weekend so that we can keep up with our work. You know what I'm saying? So I checked your homework. I realized like most of you, I mean 90% of you finished homework 1.1. And then about 70% finished up to homework 1.3. So I do hope you can like work on your homework, okay? So yeah, and don't forget your homework. You have unlimited attempts, so you can review your homework multiple times to increase your score, right? Have you tried to do your homework like more than one time? Yes. So you can improve your score. If you open a second attempt, the Mobius will remember your correct answer in the first attempt. So you only need to do the problems that you got wrong. Okay? So I also like here some students they work on homework but they didn't submit because there are some problems they didn't get it right. It's okay. You can submit your homework and then you can open a second attempt. Then you can work on the problems that you missed. Okay, everybody? So that I can see, oh, you're working on the homework. Okay, then I know. Otherwise, you receive tons of my emails. Okay, and so that is the homework. I also realized there are some confusion about the homework. Okay, some of you thought the Mobius lessons are the homework, which is not. So on the blackboard, the Mobius lessons, this is like an interactive textbook. So each day we'll go over some sessions, right? You can look at those sessions. They're like a textbook, and they have some exercise here. But for example, here there is a exercise like at the end here. Like these are extra exercise. The scores are not collected. So you can work on those as extra exercise. But those are not your homework. Is that clear, everybody? The Mobius lessons you review it before class. And those are like a textbook. Okay? And if you go to like chapter 0, I just created a lesson called factoring polynomial. Because when I create your quiz, I realized several of you kind of forget how to factor. That's why I put the new lesson here. So if you want practice or remind you the knowledge about factoring, please go to the Mobius lessons and chapter 0 and then click factoring polynomial. Okay? So when you click that, you can see how to find a common factor of a polynomial, how to factor a trinomial with leading coefficient 1. And do you see here, they have some exercise. You can put your answer and then you can check how did I do. And then you know whether your answer is correct or not. You can also click try another, and then it will generate a different question for you to practice. Okay, everybody? And here, factoring by grouping. This is when the leading coefficient is not 1. Okay, so yes, and these are the exercise. You can check it and you can try try another one. It can generate more practice problems. Factoring is very, very important. Do you agree? You need it in this course and in the future courses as well. And here we also have like factor a perfect square, trinomial, factor a difference of square, factor the sum and difference of cubes. So this lesson is all about factoring. If you kind of forget about those knowledge, you know where to find it. In Blackboard, and then click Mobius Lessons, Chapter 0, and factoring. Okay? Yes, everybody? Awesome. So your homework is right here. So click the homework. We have 38 homework assignments. Each is 10 points. Okay? And we dropped the 6 lowest scores. So even though I put it due September 26th, don't wait until near the deadline to do your homework. You need more time for your homework. So do it on a weekly basis. Okay? You try to finish the homework about the corresponding section over the weekend, so that you can ask me questions. Okay? If you're not available during my office hours, feel free to send me an email. I can meet you virtually at nighttime. Okay? So I need some of you at the nighttime, right? So I don't mind to meet you at like 8 or 9. We can go to our virtual classroom and meet. Okay? So try your best. Study hard and have questions, ask me. Okay? Don't wait until the end. How many of you want to get an A in this course? Raise your hand. So let's try our best to achieve our goal. Okay? All right. So that is the homework. Okay? So you can redo the homework multiple times until you get a perfect score, 10 points. Okay. And then quiz. So this is our schedule. So last Friday, we have our quiz 1. And some of you didn't do the quiz. Okay, so we have 8 quizzes. And we dropped the lowest 2. So there is no makeup quizzes after the due date. But if you know on that day you're gonna maybe travel due to a sports game, you're not able to do the quiz, then you can email me ahead of time. Then you can take the quiz 1 day or 2 days earlier. Okay? So only take the quiz before, but not after. Okay. So the next quiz will be on the Friday, September 16th. Okay. And I have graded the quizzes. So let's talk about solution first. Okay. So we have 2 problems on your quiz. Okay. You don't need to print out the sheet. You can just work on the piece of paper and then take pictures, combine into a PDF, and then submit it in Blackboard. When I set the quiz, I allow multiple attempts. That is just in case some of you have internet difficulty and don't have enough time within the 30 minutes to upload the document. That's why I set multiple attempts. So if you run out of time, you can start a second attempt right away and upload your quiz. Okay? Because when I look at each attempt, I can see like how much time you use in that attempt. Okay, maybe the second attempt you just use 1 or 2 minutes to upload your quiz. That's okay. Okay, everybody? But try your best to finish within 30 minutes. Because usually the 2 problems will take 15 minutes. Okay? So I'll give you extra time to upload in Blackboard. So usually the 2 questions will take 15 minutes of class time. And your exam will have, oh, okay, that's the attendance sheets. Thank you. The exam, I would like to give you more time. That's why you have 1.5 hours. But you still have a lot of problems, okay? So try to increase your speed. Okay. First problem. So that's why doing your homework is very important. If you do your homework before taking the quiz, then you'll be ready. And if you have questions on the homework, you can ask me, then you know how to do those kind of questions. then yeah, you will know how to do the quiz. Okay, the first problem. We want to find the domain for the following functions. Remember, domain, we look at two things. Square roots. If you see square roots, then the things inside the square roots is greater or equal to 0. Right? Everybody? Okay. And the second thing we check is, do we have fractions? If yes, then the denominator cannot be 0. Okay? And in this case, do we have square roots? Yes. So we need the things inside the square root, which is 3x minus 12, to be greater or equal to 0. And you want to solve for x. That's why we add 12 on both sides, and then divided by 3, we get x is greater or equal to 4. Okay, everybody? And then, second, do we have fraction here? Do we have fraction here? Yes. Oh, then we need the denominator cannot be 0. So that's why we need to factor it. What are the factors of 2x squared? 2x and x. What are the factors of negative 5? 1 and 5, but one of them is negative, right? And then, oh, we can group them. So if I put the 5 here and negative 5, I get 2x times negative 5 is negative 10x. And 1 times x is x. That's why negative 10x plus x is negative 9x. So this is how we factor it. Okay, everybody? So especially for those of you coming late, so my suggestion is usually watch if you come in late, if you miss some time, please check your recordings. Make sure you don't miss anything. Because some of you forget to do the quiz. But like last week on Wednesday and Friday, I remind you that we have a quiz, right? In the first couple of minutes of the class. So if you come in late, you might miss the reminder, right? So please check your recording for those minutes you missed to make sure you don't miss anything. Okay. And then, yeah, so this is how we factor it. If you need more exercise about factoring, go to the Mobius lessons. And this is chapter 0, factoring polynomials. Okay, so work on those exercises for factoring. And then, okay, after we factor it, the product of two factors is not 0. That means each of the factors cannot be 0. So we start with x, move 1 to the other side, and then divide it by 2. We get x not equal to minus 1/2. Yeah? Here, x minus 5 not equal to 0. Add 5 on both sides. So x cannot be 5. Yes, everybody? So we have 3 conditions that we need to satisfy. So real number line greater or equal to 4. So plug the 4. Because of the equal, we put a solid circle here. Yeah? And bigger on the right hand side. Not equal to negative 1/2. That means you put an empty circle at negative 1/2. Not equal to 5. Put an empty circle at 5. Yes, everybody? So that's why our domain is from 4 included. Use brackets if we want to include the endpoints. 4 to 5. Exclude the 5. So parentheses. And then union 5 to infinity. So this is problem number 1. Okay, everybody? And then number 2. Consider the piecewise function. I do apologize to you because I have a typo. I mean x greater equal to 4. Okay, so in your quiz, if you draw the graph less than equal to 4, I didn't subtract your points off. Okay, because that is my mistake. Alright, so this is what I intended. The piecewise function, it has 3 pieces. When x is less than negative 2, this is a parabola. Remember our math move? What is line? So move your hands. Line. Parabola. Cubic function. Right? Square roots. Cube roots. Right? And active value. reciprocal. Like that, right? Yeah, like that. Okay, so this is parabola. We plot points. Always plot the endpoints. The endpoint is -2. So you start at the endpoint. -2 squared is 4. So we plot -2 and 4. But do you see we don't have equal sign? So we're missing the endpoints. So you put an open circle here. Right, everybody? And please label it. Okay? Please label -2 and 4. Label it. You don't expect me to count how many bars you draw, right? Please label it. For the important points, label it. And then, okay, let's do one more point. -3 squared is 9. So, okay, here. So we connect them smoothly. This is the first piece. Okay? Second piece, 4x minus 1. This is a linear function, right? It's a line. 2 points can fix a line. So let's plot the endpoints. Okay, everybody? So plot the endpoints. -2. 4 times -2 minus 1 is -8 minus 1, which is -9, right? So -2, -9. Yeah, label it -2 and -9. And then because we have the equal sign, you put a solid circle here. Is that clear? You don't need to label everything. You just label the important points. So -9, -2, they're important. So label -9. Okay, you don't need to label -8, -7, those stuff. Is that clear, everybody? And then the other point, 4. See, fucking 4. So 4 times 4, 16 minus 1, 15. So when x equals to 4, my y is 15. And because, do you see we don't have equal sign? So we put an open circle here. We don't include the endpoints. Is that okay, everybody? And you draw a line, okay? So if you don't have a ruler, use your student ID. Yeah? You can draw a line to connect them. Okay, so that is the middle piece. And then when x is greater or equal to 4, square root, like that, right? So plug in the key points, the endpoints. 4, square root of 4 is 2. And then remember we want to plot integer points. So the next number is square root of 9. Yes? The square root of 5 is not integer. Square root of 6, no. 7, 8, So 9 works. Square root of 9 is 3. That's why 9, 3, put those 2 points, connect them smoothly. And this is the piecewise function. Okay, draw the endpoints. And then at the endpoints, figure out is open circle or solid circle. Okay? And part B, evaluate f of 3. So f of 3 is the middle piece. So 4 times 3 minus 1 is 11. And because of my mistake, if you put square root of 3, you'll be correct as well. Okay, any questions about the solution? And then let's look at your mistakes. So first of all, can I have your permission to show your mistakes? I didn't put any name on it, just the mistakes. Can I have your permission to show your mistakes? Yes, everybody? Okay? All right. So first, please upload PDF. Don't upload HEIC file because I have Windows. So I don't have I'm not able to view HEIC file. Okay, so what I did is I need to email to my phone, my iPhone, and then I open using my iPhone and then print screen and then email me back. So please don't upload HEIC file. Okay. And then let's look at this mistake. So the mistake is 4 is right here. So on the right hand side of 4. And yeah, take out those points. So open circle. That's why the domain is wrong. Okay? And then here, this piece is wrong. But your point is correct. So plot these points, then you should get this guy. Okay? And the middle piece is a line. So it's a straight line. part B is correct. Okay, let's look at this. Oh, square roots. So 3x minus 12 is greater or equal to 0. We'll get x greater or equal to 4. So it makes sense. And then here. Oh, thank you. So straight line, middle piece, okay? So straight line, middle piece, put this point and that point connected. I didn't subtract your points up because that's not mistake. Yeah. Okay, and how about here? Here it's good, but open circle. Okay, that point is missing, so open circle. And then, right, this is a solid circle. So at the end points, please indicate is it open circle or solid circle for the end point. Okay, everybody? All right. And part B is wrong. Okay, and then here you draw it. Okay, continue, draw it. And then this one, let's see. Oh, line, the middle piece is a line. And please label it, because it's hard for me to count how many bars here. Okay, so label, this is 99. And label, that is 15. Okay, everybody? And then here also means the 3x minus 2. Here, yeah, continue to draw it. And then here, yeah, that point. Okay, so if your picture is not like big enough, please redo your scale, okay, to make it fit the whole graph. So you need to go until you get 4 and 15 and show me this is an open circle. And part B, missing part B. So yeah, part B should be this. And when you upload your picture, please make sure you're able to read it. Okay? So it's so hard for me to guess what's on this picture. I think this is 4. I think this is 5. So that's correct. But then, you know what I'm saying? So when you upload a picture, make sure you are able to read it. And it looks like this is B is missing, and the picture, yeah. So make sure you're able to read it, okay? And then here, yeah. So this is greater or equal, so greater or equal to 4, and this is not equal. So okay. So when I grade your quiz or your exam, even though you get the right answer at the last step, if your process has some mistakes, some points will be off. So unlike you do your homework, you just enter the final answer in Mobius, and then you get the problem right. But when you do your quiz and your exams, I look at all your work. Okay? So make sure you write the process is correct. Okay. And then yeah, here you keep going and open circle there. Okay, yeah, keep going. Solid circle, open circle. Yeah, here also miss that. You can see a lot of you make this mistake. It's okay to make mistakes. A lot of people make mistakes. So we learn from our mistakes and do well on the exam. So in our course, homework is 5%, quiz is 5%, but your exam is a lot. Okay, so homework and quiz it just like help you to master the material so that you can do well on the exam. So we learn from our mistakes. Okay, so if you get like a lower score on quizzes, it's okay. I would rather you get low score on the quizzes but high scores on the exam. Do you agree? Yes. Okay. And then here, denominator not equal to 0. And then you need the things inside the square root to be greater or equal to 0. Okay. And then this is, not equal. That's why you take out the 5. And here, yeah, also that the things inside the square roots. And here, yeah, draw that and miss part B. And yeah, here forget to draw the picture. And yeah, forget to draw the chord and write down the interval. Okay, and then these students, you don't need to type it. You can write on a piece of paper and then take pictures of your work. Okay, you don't need to type your answer. Just you cannot. I don't think you have enough time in 30 minutes to type everything. So you can write on a piece of paper and then take pictures. Okay. And I don't remember who made those mistakes. So yeah. Okay. So just make sure you write on a piece of paper. And then this one, oh yeah, forget that. And this is the open circle and part B. And yeah, here plot the points and connect them. And then here, yeah, this is 11. And this, yeah, this is an open circle. And yeah, so yeah, label, okay? Because if you don't label it, this is wrong. 1, 2, 3, 4, 5. This is not -5. This is -9. That's why you label. Then you tell me, oh, this is -9. This is not -5. Okay, everybody? Please make sure you label it. And here, square root of 3 is square root of 3. So not 3. Okay. And yeah, similar. Yeah, so -5, not 6. And similar mistake, right? And then the endpoint and part B, yeah, similar, the 3x minus 12 and the endpoint. And then here, yeah, you have to show your work. So you have to show why this is not 0. So even though your final answer is correct, but if you miss the work, you lose points. Okay, everybody? So on the exam, please show all your work. Okay? Otherwise, some points will be off. And then, yes, so this is number 2. Okay, yeah. So similar. Oh, that's it. So from now on the quizzes, I will break down and I will collect the mistakes so we go over together. It's okay to make mistakes, especially in a math course. If we make a mistake, we just throw out that piece of paper and get another one and then work on it, right? It's not dangerous like chemistry. If you put something and you say boom, it might explode. But in our math class, it's okay to make mistakes. Sometimes you see I make mistakes too, right? So please check your answers carefully. If you have like extra time after you finish your exam, so check it 3 times if you have extra time. Okay. Any questions about the quiz? They're all good? Mm-hmm. Awesome. Is this your first semester at Tech? If yes, raise your hand. Okay. So good. So that's why you still need time to like get used to the university style, right? Mm-hmm. Okay. Good. All right. So let's see. Okay, let's continue on session 1.6. So last time we talked about how to solve equations involving absolute value, right? First, if the variable is only inside the absolute value, we want to isolate the absolute value. And then we want to break it using the rule that absolute value of x equals to a, that means x equals to a or x equals to minus a. Do you remember that? Mm-hmm. And then we can solve for x. If x is inside and outside of the absolute value, then what you should do is separate them. Okay? The first one just get rid of the absolute value. The second one we replace it with negative of that. Do you remember, everybody? And then you solve for it. At the end, you have to check your work. Okay, so you have to check all your solutions, plug it in, and see if the left-hand side equals the right-hand side. Yeah, so if you use this way, you have to check your solutions. Okay, and then today, let's continue to solve inequalities involving absolute value. So let's see, inequality involving absolute value. So, okay, let me use some green color. Okay, let's talk about the theory. Okay, how do you break the absolute value of x less than or equal to a? How do we break that? Well, what does that mean? So absolute value of x, this is the distance between x and the origin, right? So if we draw the picture, this is the origin, and a is right here, negative a is right here. Yes, everybody? So we're talking about the distance between x and the origin is less than or equal to a. That means we are here. If the distance between x and the origin is small. Yeah, distance is small. That means it should be light in this interval. Think about it at the endpoint. At the endpoint, the distance is a. Yes, everybody? So the distance is smaller than or equal to a. That means this is inside the interval. So we have a smaller distance. Do you agree, everybody? Distance is small, so inside the interval. How about when distance is big? Okay, so when the distance is big, then we have a 0 here, minus a and a. Distance is big, so far away from it, the origin. That's why it's outside. So think about distance small, inside, between minus a and a. Distance big, outside. Outside means either less than negative a or greater than a. Okay, everybody? So this is how we break the absolute value inequality. Distance small, so that means x is bounded between minus a and a. Distance big, that means it's outside. So x is less than minus a or x is greater than a. Yes? Yeah, so you can use the sentence distance small, that is inside the interval. Okay, so inside. And distance big, then it's outside. Okay, so you can use this to help you to remember. Is it between minus a and a or outside of that? Okay. And what are the steps to solve inequality with absolute value? The first thing we do is isolate the absolute value. Okay, so the absolute value term is on one side by itself. All the other terms is on the other side. Okay, that's the first step. Second step, we're gonna break the absolute value. So break the absolute value using these rules. Okay, inside or outside, and then solve for x. Okay, so let's follow these steps. First, isolate the absolute value. So what shall we do? Subtract 1. Yeah, so subtract 1 on both sides. Then we have 2 times absolute value of x minus 5 less than or equal to what? 9 minus 1 is 8. Yes, everybody? Okay, and then what do we do? Divided by 2. By the way, when we work with inequality, add or subtract the number won't change the inequality. Multiply or divided by a positive number won't change the inequality. But when we multiply or divide by a negative number, then it will change. It couldn't, right? Yes. So here we're dividing by 2, so it's okay. We still have absolute value of x minus 5 less than or equal to what? 4. Nice. Now we have isolated the absolute value. So how do we break it? See? Distance. This is small or big? Small. Yeah, less than equal to something. Distance is small. That is inside. So inside, that means between -4 and 4. Okay? Do we count the 4? Yes, because equal. So we have x minus 5 is bounded between -4 and 4. Yes. How do we solve x? We add 5. So this is a compound inequality. It has 3 sides, not just 2 sides, not just left hand side, right hand side. It has 3 sides. So you must add 5 on all 3 of them. So we add 5 here, here, and here. Yes, everybody? Okay. -4 plus 5 is what? 1. And then we have x. And 4 plus 5? 9. Great. So this is the answer. If we use interval notation, so 1 and 9 include the endpoints. So this is the interval notation. So far, so good, everybody? Yes. Okay, awesome. Let's continue. Okay. Next problem. What do we do first? Subtract 1. So subtract 1. We get -2, absolute value, 3x plus 7. What's -17 minus 1? -18. Very good. Okay, what do we do next? Divided by -2. Oh, on the left-hand side, we divide by -2. We got this absolute value. What's -18 divided by -2? That is 9. What happened to the inequality? Flip. So we get less than 9. Yes, everybody? Okay. So we already isolated it. What's the next step? Break it. Is distance big or small? Big? Distance less than some number. So big or small? Small. Then it means it's bounded between what? Yeah, -9 and 9. So -9 bounded between. Do we have equal sign or not? No. Is that okay, everybody? So we have that thing inside the square root is bounded between -9 and 9. Not include the 9. Okay? What do we do next? Subtract 7. Very good. What's -9 minus 7? Yeah. 9 minus 7? 2. Then what do we do? Yeah, divide by 3. Will that change the inequality? No, right? 3 is a positive number. It won't change the inequality. Nice. So that's our answer. So -16 over 3, not include the endpoint. 2/3, not include the endpoint. If we want to use interval notation. So this is how we solve inequality involving absolute value. Yes, everybody? Okay. Next, we're going to solve different types of equation. So first of all, how do we solve polynomial equation of degree greater than 2? If we have degree equal to 2, you have the quadratic formula, right, everybody? So what happened? Trinomial equation of degree greater than 2. So first, we write it so that all the terms are on one side of the equations. So the 0 is on the other side. So move all terms on one hand side. So 0 is on the other side. And then factor completely into linear and quadratic factors. Okay, so let's look at this example. What do we do? Do you see these terms? We should move all the terms to the left-hand side, right? Subtract 2x. Then we have x cubed minus x squared minus 2x equals 0. Yes, everybody? So we have all the terms on one hand side and the other side is 0. Okay. And then let's try to factor. Do you see a common factor here? X. So, power means x times x times x. Yeah, so this is x times x. So x is still a common factor. Yeah, so we factor out x. What's left? Yeah, very good. Nice. Let's continue. Can we factor this trinomial? So x and then what? Yeah, very good. Are you okay, everybody? So minus 2x plus x will give us negative x. So this is how we factor it. Okay, now we have the product of lots of factors equal to 0. That means, so we have x is 0, or x minus 2 is 0, or the x plus 1 equals 0. So you set each factor equal to 0, and you put or to connect them. Okay, everybody? Yeah, so 0, 2, or what? Negative 1, yeah. So these are the solutions. So far, so good, everybody. We have 3 solutions. So in general, degree 3, then we should have 3 solutions. Sometimes what we might have some repeated roots. Repeated roots, for example, if you have if you have this guy, so this is like x equals to 2, x equals to minus 1. You see the multiplicity? The multiplicity is the power of that factor. Yeah? So this guy, x equals to 2, has multiplicity 2. So this is like a double root. Okay? So in general, degree 3, we should have 3 roots. Counting multiplicity. So you might have 2 roots, but one of them is multiplicity 2. In general, polynomial of degree n should have n roots, counting multiplicity. So far, so good, everybody? Awesome. We'll talk about those later when we study polynomial. Okay, how about this thing? If we have, so first of all, do we have common factors of all those 4 terms? No. Okay. So if you see 3 terms, you try to factor it, the product of 2 factors. So if you see 4 terms, try to group them. Okay? We group the first 2 terms together and group the last 2 terms together. So group them. Can you see a common factor for the first 2 terms? What is that? X squared. Oh, we factored that. What's left? Yes. And then look at the last 2 terms. Can you see a common factor? 3. And what's left? Oh, how nice. Do you see now we have a common factor x minus 3? Yep. Now we can factor out x minus 3. And then what's left? x squared plus 3. So this is how we factor it. Yes. Okay, so if we see 4 terms grouped down into pairs. Yeah, we get x minus 3 is 0, or x squared plus 3 is 0. So x equals to 3, but you know x squared is always greater or equal to 0. So when we add 3, the left hand side is always positive. So it won't be 0. So this guy, we don't have a real solution. So no real solution. The real means real number solution. So do you know like z? Okay, n is the natural numbers. So it's like 1, 2, 3, etc. Right? Z is the set of integer. Do you know that? So integer is like minus 2, minus 1, 0, 1, 2, 3. So those are integers. Yeah? And then the next bigger one is rational numbers. Yeah, rational numbers. That means we have like P over Q such that. So P over Q, this line means such that P and Q are integers and Q is not 0 because our denominator cannot be 0. Yes? And then the next bigger one is the set of real numbers. Yes? The set of real numbers includes rational numbers and irrational numbers. How about the bigger one? What's the set bigger than real numbers? What's this? Have you seen this? Complex numbers. Have you seen complex numbers? Yes? So this is the complex numbers. Okay. And we will have the I. I is the square root of minus 1. So if you haven't seen complex numbers, it's okay. We will study in session 3.1. So we will learn that later. Okay? So don't worry about that right now. But this guy, you realize, so how many of you know complex numbers? Okay, so for those of you who know complex numbers already, we can keep going and solve for x. So we can subtract 3 on both sides. And then when you take square roots, you get square root plus or minus square root of negative 3. That is a plus or minus square root of 3i. Because I is square root of negative 1. That's why this problem has 1 root and 2 complex roots. It has 3 roots total. Yes. Yeah, I is imaginary numbers. Exactly. So complex numbers, it can be written in the form of a plus bi, such that a, b are real numbers. And we call a is the real parts, and b is the imaginary parts. Okay, so if you don't know this, it's okay. We will learn those in session 3.1. Okay, we're now in session 1.6. So we will learn those later. Okay. Any questions about this problem? So we only have one real solution. Okay, let's keep going. Next one, rational expressions. So if you have an equation involving rational expressions, we write it so that all terms are on one side of the equation and 0 is on the other side. Factor each expression if possible. Find the least common denominators. Combine the rational expressions into one big fraction. Be sure to check all the answers in the original equation. Because we have rational expression, then we need to check the domain. Remember, fractions, we need the denominator cannot be 0. Right? That's why when we see this kind of problem, the first thing we check is the domain. Okay. Domain, we check all the denominators. Let's factor it. Look at this denominator. Can you see a common factor? Yes. So x, what's left? X minus 3. Yes, everybody? So this is the first denominator. We can factor it as x times x minus 3. How about this guy? Yeah, very good. X plus 3 and x minus 3. And then, this guy is x plus 3. Okay. Can we find the least common denominator? So the least common denominator should be include all the possible factors of the denominators, right? So look at this guy. Oh, we should have x, and we should have x minus 3. And then look at this guy. We don't have x plus 3, so we need to include that. Yeah? So we should have x plus 3. And then x minus 3. Do we need to add a copy of x minus 3? No, we already have it. Okay? Don't double count it. And then this guy. Oh, we already have x plus 3. So good. This is the least common denominator. Yes, everybody? Then what is the domain? Domain is when the least common denominator not equal to 0. Okay, so not equal to 0. That means x cannot be 0, x minus 3 cannot be 0, and x plus 3 cannot be 0. Yes, everybody? You said each factor cannot be 0. So x cannot be 0. How about this guy? X cannot be what? 3. And this guy, x cannot be -3. Is that okay, everybody? So this is the domain of x. Now we take a common denominator. Let's see. So our common denominator, okay, look at the first one. The first one we have 1 over x times x minus 3. Yeah? In order to get the common denominator, we need to multiply by what? Yeah, multiply by x plus 3. Is that okay, everybody? And then next we have subtract 2 over that guy is x plus 3, x minus 3. What do we want to multiply to get the least common denominator? What do we miss? What? X. Yes. So we multiply by x. We want to combine them, right? So we find the least common denominator and see what do we miss. Here we have x minus 3 and x, that's good. But we miss x plus 3. That's why we multiply by x plus 3 on the numerator and denominator. And then this fraction, we have x minus 3, x plus 3. But we're missing x. Yes? So we multiply by x on top and bottom. And keep going. Equals right hand side 1 over x plus 3. What do we want to multiply? X minus 3 and x. Yes, everybody? Yes. So now you can combine them. Okay, so now on the left hand side, we have the common denominator is x, x minus 3, and x plus 3. And then the first term we have x plus 3 minus 2x. Is that okay, everybody? Yes? And then on the right-hand side, we have x plus 3, x minus 3 times x. And the numerator, we have x minus 3 times x. Let's distribute it. So we have what? X times x is x squared minus 3x. Yes, everybody? Okay, nice. Now I can both sides multiply the least common denominator to get rid of that. So both sides multiply by the least common denominator. Do you see now the denominators cancel? Then we are left with x plus 3 minus 2x equals x squared minus 3x. Is that okay? Right? So I hope you can take notes, and then if you have questions, ask me. Our class ended 157. Yes. Oh, okay. But promise me you'll watch the recording for those 7 minutes. Okay? Yes. All right. Keep going. Do you see now we have a quadratic equations? So move all the terms on one hand side. Should we move the terms to the left or move the terms to the right? To the right, because we want the x squared to be positive. Right. Oh, by the way, what's x minus 2x? Negative x, right? Okay, move to the right, so we add the x, and we also subtract 3. Is that okay? Then we have x squared. How many x? Negative 2x and minus 3. Oh, that equals 0. Yes, everybody? Okay, so we either factor it or use quadratic formula. How can we factor it? We got, minus 3 plus 1. Okay, nice. So we have x minus 3 equals to 0, or x plus 1 equals 0. Yeah, 3 or negative 1. Are we done? Not yet. Why? You need to check whether these are in the domain. See? Can x be 3? No! See? We gotta check. So check the domain. X cannot be 3. So the only solution is x equals negative 1. Okay? So this is how we solve equations involving rational expressions. Any questions about this problem? We'll keep going. Okay? So next one. Okay. All right, so solve this. Solve the equation with radical expressions. Okay, so if you have to leave earlier, then make sure you watch the recording. Okay, our class should end at 1:57. Okay, so let's look at this one. Okay, so first, we want to write it so that the different radical terms are on the opposite sides, and then we square both sides. You may need to repeat this process to eliminate all the radicals. And make sure to check your answers in the original equations. Okay, so first, let's separate them. Okay, so let's isolate one of the radicals. So let's move this thing to the other side. So we add square root of x minus 4. So we add that on both sides. We get square root of x plus 4 equals
2 plus square root of x minus 4. Is that okay, everybody? Oh, by the way, is this thing equals to square root of x plus square root of 4? So it equals square root of x plus 2. Are they equal? No! Don't ever break it. Okay, we cannot do that. That's why we need to isolate one of the radical terms. And then so move this to the other side. To get rid of the radical, we square both sides. So square both sides. Okay, so when we square it, the square root and square cancel. So we have x plus 4. Okay, but on the other side, when you square it, remember you have the formula a plus b squared equals a squared plus 2ab plus b squared. Yes? And if you have minus, then you have a minus. So, that's why this is like our a, this is like our b. A squared will be 2 squared. You agree? Plus 2ab. A is 2, b is this radical x minus 4. Plus b squared. Is that okay, everybody? Mm-hmm. All right, we keep going. So x plus 4 equals 4 plus 2 times 2, 4 square root of x minus 4 plus square root and square cancel, x minus 4. Yes, everybody? Okay, and then what do we do next? Isolate the radical term. So move all the other terms on the other side. Okay, because you want to isolate it and then you can square both sides to get rid of the radical. So let's see. Oh, do you see the 4 and minus 4 cancel? And I can subtract x on both sides. Do you agree? Then we have 4 equals 4 square root of x minus 4. Yes, everybody? Mm-hmm. And let's continue. Isolate it. So what do we do next? Divided by 4, right? Isolated, so get rid of the 4. Then we have 1 equals square root of x minus 4. Okay, awesome. Now we're ready to square both sides. 1 square is, so square both sides. We get 1 square is 1 equals x minus 4. What is x? 5. Okay, and then you need to check. Okay, so need to check. So plug 5 into our original equations. Square root of 5 plus 4 minus square root of 5 minus 4, is that equal to 2? What is 5 plus 4? What's square root of 9? 3. 5 minus 4? 1, right? Square root of 1? 1. Is 3 minus 1 equal to 2? Yes. So x equals to 5 is the solution. Okay, everybody? So you need to check whether it is a solution. And then here, because today I'm supposed to finish this session, so I will let you to do the next 2 problems at home. But I kind of mentioned a similar idea. Okay, so a similar idea. You kind of isolate. Yeah, it's already isolated and square both sides to get rid of that. Then you can solve the corresponding quadratic equation and check your answers. And then if you have two square roots, it will take more time. So you isolate one radical, square it, and isolate the other radical and square it, and then solve that. It will take more time. So every step you isolate one radical and square it to get it out.